Students, in this video I'm going to go over a couple of examples of solving linear to quadratic systems of equations, as well as quadratic to quadratic systems of equations. So let's take a look. So this is a system, right? And like any system, when we have multiple variables, okay, it is important for us to eliminate some of them. So I'm looking at this right now. It is possible for me to reduce the number of variables here down to just one. Right now, it looks like I should be able to eliminate y's. So that's what I'm going to do. So I have 3x squared minus 4x plus 2y. I want to I'm going to bring the 14 over to the other side. Or actually, no, I'm going to leave the 14 over here. What am I saying? So I have 14, okay, and then I have x plus y equal to -1, right? I'm going to do the same thing. I'm going to bring everything over. So I have x plus y plus 1 is equal to 0. And what I want to do with this is I want to eliminate the y's. So to do that, I am going to multiply the bottom equation by -2. And if I do that, this will transition into 3x squared minus 4x plus 2y plus 14 is equal to 0. And then here I have -2x minus 2y minus 2 is equal to 0. And then all I got to do from this point is to add the two equations. So if I do, I'll end up with 3x squared minus 6x. The y's will go away, and I end up with plus 12 is equal to 0. And looking at this thing is factorable. I'm going to divide both sides by 3, and if I do that, I'll end up with x squared minus 2x plus 4 is equal to 0. And further looking at this, okay, x squared minus 2x plus 4, is this thing factorable? Are there two numbers that multiplied 4 but then add to -2? It doesn't appear that way. That doesn't necessarily mean that we won't have an answer. So let's try to use the quadratic formula here. If that's the case, then I have -b, which is going to be +2, plus or minus square root b squared, which is going to be 4, minus 4ac, minus 4 times 1 times 4, all over 2a. So right now, okay, what I'm going to end up with is, okay, because I'm solving the system of equation here, I'm not going to end up with any real answers. And the reason is, if you look at what's inside of the square root, that 4 minus 4ac, that b squared minus 4ac, that reduces to -12. That b squared minus 4ac actually has a name in mathematics, and we refer to that as the discriminant. And here we end up with no real roots, right? So in other words, if we're solving the system of equation here, we're solving for the point of intersection, there will not be any real solutions here. Okay, so there's no solutions here. No real solutions, I should say. No real solutions. There are imaginary roots, okay? However, our goal here is to not find the imaginary roots, but to solve for only the real solutions in this case. All right, let's take a look at the next one. Very similar, okay? What I'm going to do, again, everything's already brought over to one side. So what I'm going to do, I'm going to try to eliminate the y's again. So I have, whoops, did not mean to do that. So this is where I'm up to. What I'm going to do, again, I am going to rearrange everything. So that I have x squared minus x minus y plus 4 equal to 0. I have -3x, and then I have y over here, and again equal to 0. So all I got to do, because the y's have the same coefficient but opposite signs, all I got to do is just add the two equations together. I'll end up with x squared minus 4x plus 4 is equal to 0. Are there two numbers that multiply to positive 4 and add to negative 4? Absolutely. That's negative 2 and negative 2. So it's x minus 2 quantity squared. This is a perfect square. So in other words, okay, x will equal to 2. So since x is equal to 2, okay, I can then solve for what the y-coordinates are. So what will the y-coordinate be? I can plug x back into either one of these, and it will be okay. So if I take x equal to 2 and substitute it back into the linear form, because that's the easier one, that would make the most sense. So I have negative 3 times 2 plus y is equal to 0. In other words, y is equal to 6. So that's my solution there. All right, moving on. Okay. So in this case, okay, everything's already brought to one side. I am just going to rearrange this just a little more. I have x squared minus 5x minus 2y equal to 0. And then I have x plus y minus 2 is equal to 0. I want to multiply the bottom equation here by positive 2 because I want the y's to cancel. So I end up with x squared minus, minus 3x. And then the y's will cancel, and minus 4 is equal to 0. Now that I have this, okay, is this thing factorable? As it turns out, it is. So it's x minus 4, x plus 1. So therefore, now I end up with two roots. I have 4 and negative 1. All right. So now that I have 4 and negative 1, I'm going to take this and I'm going to substitute it back into the linear equation because that's the easier one to work with. So if I do that, I end up with 4 plus y minus 2 is equal to 0. So in other words, I end up with y is equal to negative 2. So my first coordinate will be 4, comma, negative 2. My second coordinate, I'm going to again repeat this. So I have negative 1 plus y minus 2 is equal to 0. Or in other words, y will equal to 3. Or my second solution is negative 1, comma, positive 3. Okay?